It doesn't now.
Yeah, we
It's
actually,
way worse
we
than
get
that.
paid 10.5.
Alright.
Few words. I
I'm
heard you yell.
supposed to, I'm not gonna.
Okay.
He's not gonna show up.
Hey,
It's
Okay.
only 2 hours.
alright, let's walk through the two types of problems I want to go to. Today I have basically 3 different examples that I picked that I want to go through that are pretty quick. All the homework is roughly the same. You're figuring out, do you have a linear growth or is it exponential? And if it's exponential, what's the formula for it? That type of thing. Because linear is pretty easy. So let's go through a couple examples. So let's talk about our function here. 15.
When did we change to 1.2?
1.3 to the x.
Did we change to 1.2 today, or was that yesterday?
That was 2 days ago.
No!
Okay, alright.
Yo, you
I
know
thought we were
what
in
we know,
1.6.
It's on the
Since we've been here forever.
Yeah, but I want you to make it like, hey, everyone, new section today.
New section
1.2.
Tuesday.
Okay, alright.
Do you ever get like August and September confused?
Yes.
No, moving on. Alright, so, alright. Now, on this part here, when you first look at it,
Exponential.
one of the first questions we'll ask, is it exponential or linear?
It's exponential.
Exponential has a very little up and power.
Happy birthday.
And second, is it gonna be growth or is it decay?
It's growth.
It's growth. Now let's
This
talk
is
about what.
1.3.
Boom. Okay.
So it's increasing by itself plus 30%.
The base is gonna tell you if it's growing or shrinking, and you're absolutely right. This is growth, and it's by basically 30% growth on top, because it's 1.3. By looking at a function, you can immediately tell if it's growing or shrinking because of that number. Now, the second part here, second example with this, I'm still in these same types.
Okay. How's your day today?
What day today is these? That is a shrinking exponential.
I shared my
Hey.
freaking food with
Okay, this is definitely a shrinking type of problem because your base here is decaying by 25%.
Right.
So this is a decay,
Why are you guys all doing that to me?
25% decay.
This will work.
We need to make sure that you can understand the difference right when you look at it. Now, these are the typical functions you guys have been seeing the last couple days with me.
Right.
There's exponential where it uses the natural number, like the natural number e. So the natural number e is this. E to the 0.05x. You can put 157 out front. Maybe this is my next function. This problem is still growth. Even though you're looking at it, you're looking at it saying, okay, that's a 0.05. That looks like it's shrinking. On a natural number problem, the base is 2.7. And so you're still going to be above 1 even though you put some numbers up here. How you can tell by looking up here whether it's growing or shrinking, is it positive or negative? That's how you can tell on a natural number problem. So this is growth. That's a growth problem. If it's decay, it'll look like this.
Oh wait, let me guess.
This is always negative 0.05.
Yeah, so whatever the E is,
Wait, so I have a question here. If that means it's decaying.
Cindy, would you throw me one Cheerio?
Like straight
Okay, I have a
up.
question.
No,
So, on the first two, if it's above 1, it's growth.
hey, I can't even hear. She's
Yes.
right in the front row. Stop talking. Get your feet off my desk.
On the first two, if it's above 1, it's growth, right?
Yeah.
If it's below, okay. And then on the second ones, if it's positive, it's growth.
Positive.
And it, wait, the
Yeah, but it has to be on the
157,
natural number.
wait, is the 157 the positive number or the 0.5?
Yes,
Oh,
the number I'm
okay.
circling. That number has to be positive.
You are so random.
Okay. Questions on growth versus decay.
No.
You have a lot of problems where it just asks for that. That's very simple. Very easy calculation. Now, that's the first problem. We're done with it. We're moving on. The second part we're going to be doing, talking about graphs or data.
Data.
If you're going to take it and try to come up with a formula for it. So I'm going to go through 2 examples of it just to make sure you can see this. So the first example. First example, if I give you a graph and they give you a couple data points on it. Like, so here's my graph. We already know it's exponential by looking at the graph, but they're gonna give you some form of information. Let's say this is 5, 3, and this is 1, 1. Let's say that that's my function of some type. It's some type of exponential. It wants to know what is a potential function, like a formula that you can come up with for that graph. It doesn't have to be perfect, as long as it has data that's somewhat accurate. So, data, or whatever you want to call it. Now, let's walk through this problem. This problem you're going to want to write down somewhere in your notes.
You're gonna want to, it's gonna be a homework assignment, kiddos.
What number is it in the book?
Wait, are we done now? Can you tell us what it is? Oh.
We have one more problem after this.
Oh, here's my top notes.
Okay, but your one more problem takes 10 minutes.
Yes, it does.
So you complain, it will take 10 minutes.
Well, no, I wasn't complaining, I was just justifying my answer.
In a few months or what?
Okay,
Where is the trash can?
all
Right
right.
here behind me.
Okay, here we go. First step. The
How
x's,
am I expected to get through this?
the x's are off by more than 1, the x values. So that means we're gonna have to do that little check that I did yesterday to figure out what the growth rate is on this problem. So the function looks like this.
Q equals.
And I'm gonna plug in the numbers in here where this is what we have. That this is we don't know what the initial number was. The initial number was in this range. I don't know what it was. It's not 0, it's not 1, it's somewhere in this range. So I don't know it, so I'm gonna leave Q to the O. Q to the O here is Q naught. It's the initial amount that you started with. I don't know it, so I'm just gonna leave it a variable. A is the base. If you wanna put just the word base here, you can.
Base.
I don't really care. We're gonna try to figure out what the base number is. We're trying to figure out the growth or decay. Obviously this one's growing. So the number we get out of here better be positive, it better be bigger than 1. And we need to use this. Now where I came up with this formula, it's using this first coordinate. The 3 is gonna represent the value coming out. The 5 is gonna represent the time frame plugging in, the x that you're plugging into it. Because these are exponentials. The numbers goes into the x coordinate.
What are you trying to figure out?
We're gonna try to figure out the growth. Like the actual number that's growing by, it's growing by
Okay.
10%, 15%. What is it doing?
You wanna know what I've noticed?
What?
Every time I come in this classroom, I get a headache.
Good.
What are you trying to
Now,
Because he has that apple orchard
Alright.
stuff.
Is that what it is?
next.
What did you?
I think it's in my, I don't
No, it's not.
know, I can't think of the one.
All right, the next one. Okay, so here's my next one. So whatever these are, what I'm gonna do is I'm gonna divide these out. So I usually take the rightmost coordinate, so the one that's on the right, and that's the one that I'm gonna put on the top of my function. I'm going to divide these two things from each other. I'm taking the one side and dividing by the other. What's gonna happen here is that the initial terms will drop out because they're the same if you divide them. The bases will be left, but I can subtract the base powers from each other. So the base will be left on the top because they're the same base, but it's gonna be a 4 on the top because it's a cancellation rule from the laws of exponents.
So it's 3. It's
So-
gonna be equal to 3.
And then that's gonna be equal to 3. And then all we have to do to figure out what the base is take the 4 to the other side and take the 4th root.
Exactly.
Because this will tell you its growth, because it's an exponential. So if we take the 4 to the other side, that'll be a 4th root of the number 3. Now we already know it's probably gonna be positive because it's growing. And this is gonna be my base. This is what we're growing by. So this is where you need to calculate. I would want to go to about 3 or 4 decimal places, type in the 4th root of the number 3. Now again, on a calculator, this is how you type it. 3 little caret, type in 1/4 in there. Because putting the 1/4 will allow you to take a 4th root of that function. Say again?
Oh.
1.316.
Hey, someone left.
074
Yeah, that was just Katie.
Is that it?
Sure.
Yeah.
1.31?
No.
Okay.
She didn't.
So it's about 31% growth.
I thought you were
That's pretty good.
class last.
That is
Is that what we're getting?
No, it's 1.3.
1.6074013.
6.
6.2.
Sure.
That's closer. That's better.
Now, whatever the number is, 3 to 4 decimal places, as long as you're somewhat accurate, I'll give it to you. And now that we know what my growth is, the question in the book was, come up with a function of an actual formula that represents this graph. So, pretty easy. We already know the base.
Can I just borrow it?
So, we know the base is, what is my base? 1.31607, that's my base number.
Yep.
I have some number plugged in. In this case, I can be plugging in the 5 into it. But this would represent my function. Because it's just a random function, they say that somewhat represents your data. This one
How
doesn't.
did you decide to put the 5 there?
I just picked one of the 2 coordinates and I plugged the X number in. The book sometimes will plug the Y number in and just like set it equal to 3 on the other side. But for the most part, from what I can tell, they always just pick one of the 2 coordinates and plug it in and say, hey, this is roughly what you're getting.
So wait, what does QO mean? That's the initial amount.
That's the initial amount. I just don't know that number. So sometimes the book will just plug in one of the values into the initial if you happen to know.
Why is it a 5 and not a 1 there?
Let me just double check because
I think it's close.
There's a 5 on that one and a 1 on the bottom one, so I don't understand.
Oh, yeah, I don't understand either.
How do we find the 5 there?
they just pick one of the 2 coordinates. So they just plug the number into the X. Let's
Hey,
see.
the vegetarian might
One of the
change it.
function.
You want it? Yeah, literally change it. Don't put it on
Yeah.
Oh, over there.
Some of the functions, they actually give you the initial number. So in the back of the book, sometimes they give you this number.
Yeah.
They just give you that. So they actually gave you that coordinate. That number can go here. Because that's the initial amount that they
I feel like that
threw
would
in.
make way more sense than putting a random 5
Yeah, so
down.
they'll pick one of the coordinates, but it's one of the coordinates.
Yeah, that
Yeah.
makes sense.
Variable is
So,
an X.
but sometimes they tell you the initial amount. So, the book is pretty straightforward. They just give you that number right away. That's
They give it you?
Yeah.
Oh, yeah. Yeah.
Okay. Hey, let's move on to the last problem today. So that's so if they ask you to come up with a function, it's the best way to do it is this route right here. Okay. Last problem today.
Q formula and then the base.
That's probably the day.
Last problem. I gotta give you a function here.
No.
All right. Here's the function I'd like you to write down.
I was watching that.
All right.
I gotta go.
Q
To get that.
Well, we said like shut up, get your feet off my desk.
equals S1 minus E negative KT.
There was a reason as to why we.
All right.
AT just walked in here.
Maybe there was.
All right.
I would just like.
What you're looking at here, this problem, what they have written, is different than anything we've seen up till this point. It resembles an exponential function. The difference here, this one has a limit to it. Why it has a limit? They're taking 1 minus the number, so it's got a growth. So what's happening, what this graph actually represents is something like this. As your S increases this direction, these are the S's, these are the numbers I'm using, right? I can use S's on the X-axis.
Okay, yeah, well.
The Q number is going up this direction.
So it's a direct.
So-
Direct.
It's a limit, it's a quadratic, or not a quadratic, a exponential, but what happens here,
Direct correlation.
yeah. What's gonna happen here is that there is gonna be a limit to this graph.
Should I bring my
The
phone?
limit to this graph is typically the number
How do we know
that,
it's a growth?
they're subtracting the negative, so this is a really small
Oh.
number. So overall, this will be,
Have we learned
it'll
this
be,
before? We have.
we've learned this part, where that's shrinking, but if you subtract a shrinking from like 1 minus a
But what
shrink.
you're doing with the graph and then.
Yeah, we've learned like we've learned limits, like where you've seen it, we just never
We've
called
learned
it that.
limits. Oh my goodness, the limit does not exist.
So,
Have you seen the limit before?
yeah. All right. Now, the number that's involved here.
Someone asked me if
The
we learned
S.
limits before. I was like, no, because I didn't know we've learned them.
This number that's along the y-axis.
The chair's gonna fly to
Hey, we gotta stop talking. Signal it. horizontal asymptote. The S number is that number. So the number that's sitting right here, that's in this S location, whatever number that is, that's the number for the horizontal asymptote. That's gonna be, the number is gonna be S, whatever that value is. So if there was like a 5 sitting there, your limit at this function where it's gonna increase to a certain point will be 5. That'll be the max it will ever hit. It'll be as close to that. So it doesn't matter how many times. So I think the example they used in the book was like, I think this is like, if you were to ingest like a Tylenol capsule, okay? And so if you were to ingest it, and you ingest more, at some point your body will be saturated where you can't absorb any more of it.
That's actually
And yeah, it's an actual thing.
That's how you die.
And so, yeah, basically. And the idea is that the limit
Does not
is,
exist.
it doesn't matter that you're taking more. There's a limit to what your body can actually like process, and this would be the process metabolism of your body.
That's like people
So,
overdose.
what?
That's like people OD.
Yeah, basically they cross that threshold and their body can't process it anymore, and so their just organs shut down because your body is trying everything in its potential to try to absorb that material. So the brain is basically concentrating on the one organ that's having basically a panic attack.
So how many do you think it takes hours?
What?
How many do you think I could take without like?
I'm not telling you that. That's no question. No.
That, he does not have the answer to that. So I've tried it and it's not 12.
What?
But if I take 13,
take
that's
two.
crossing.
Because if they gave you a growth and they give you a time frame, they give you this S, you could just plug the numbers in and you have it. It's a very straightforward problem, but the one that always gets people is like knowing what your max is, that's the S out front. Now, where we've seen this type of problem, we did this for exponential growth and decay for populations. That's what we saw. We just had a slightly different formula. Because I moved the numbers around. I think where you guys have seen this problem before is I think I did a problem like this
Yeah,
in
you do like
pre-cal.
Half-Life.
Yeah, it was like it was a story problem where I put like a city population on the top, and then I put numbers like this.
Oh, yeah.
That's the problem we've done previously. Because all I did was I already moved that stuff down.
Mr. Ward, you tricked a lot of people up on a test pre-calc.
Yeah.
Eat a dog.
It happens.
Eat a dog.
Alright. I just wanted to give you that formula. That's something that the book will ask you what's the limit. Number. Okay,
So
homework.
S is the limit.
Homework, here we go. It is page.
Mr. Ward, what type of bear is best?
The honey badger.
I don't think that's it.
Alright.
Well, black bear. Bears. Bears.
Well, start with that, guys.
I don't know.
Sydney,
Oh, yeah.
What?
See, good, I was gonna.
How's that you, Dwight? We're not seeing race.
I can't talk over top of you. I don't have the one power forward. Page 17. 2 through 4. 6, 7, 9, 10, 13, 17. Actually, 13 through 17.
Ooh, Mr. Ward.
19,
Okay, what?
22,
There's a lot of them.
24,
Do you have hand sanitizer?
31.
That's the least you could do for me. You wanna read them again?
Through Tuesday.
That's a lot of problems.
4,
Sydney, don't coddle your immune system. That's so bad. You should
No.
welcome other people sneezing.
I'm
Okay.
not that kind of person.
Now, some of the problems, as simple as, I'm not talking about like 2 through 4, the later problems in the middle, it's simple as they say, look at this function, is it growing or decaying? That's it, that's the only question I ask.
How many? Would you like to drive? Yeah, all of them?
Hey, Mr. Ward.
Give your So I'll drive to
I'll
your
write that down.
house.
Mr.
You
Shore.
can drive to your house if you'd like. Drop your stuff off, then come to me.
Okay, so I asked him what I wrote. Like, throwing them on the up, and he's like, I played football.
Mr. Ward, you do anything over your